Good evening, one and all. Thank you for coming to this session. I am Srikanth. I am working as an architect at OSI Digital.
And I am Charan Teja, currently working as an ML engineer at OSI Digital. I am passionate about artificial intelligence and machine learning. And in my free time, I try to overload myself. I'm not audible. Okay. I'm audible now. Okay. And in my free time, I try to overload myself with these updates related to artificial intelligence and machine learning, since the pace at which it's going is really rapid. And I'm also actively solving problems on lead code. I'm also into computer programming. And I'm one of those engineers that Srikanth touches on a day-to-day basis.
Thank you for the great introduction. Not even planned. Okay, cool. So what do I do on a day when I don't work? I just go back to community. I love working with students, giving back to the community. So I conduct sessions on different technologies. And besides that, I used to do karate, YouTube, blogs, and a lot of things. Used to be until recently because it has been replaced by my little one. So this is my new day every weekend. So given that, let's start with the session Rags to Riches. So today we're going to share with you all how we built a chatbot using RAG and saved costs for our organization. And we'll walk you through our journey, our mistakes step by step. So you'll also get a gist of it. And we hope that you take this back to your organization, to your workplace, and implement that. So before I even start, how many of you use websites on a day-to-day basis? I mean, of course, everyone. So when you go to your organization websites, especially, so how many of you oftentimes find what you want? Okay, I don't see any hands rising up. So imagine your customers going to your organization website and wanting to find something. For example, does your organization work with ERP? Does it work with Salesforce, custom applications, machine learning? Right? So it's very difficult. And every organization, when they start their website, they start with very good intentions. That is to convey the information effectively and efficiently. But what happens over the time is there's a rapid information that is growing at a fast pace, and then your website gets bloated over time with or without a great UX. Your customers or your users who are using your website always end up feeling like this. So now this, we are no different at our organization. We had the same challenge and we wanted to change something. And just like everyone and just like all the talks or most of the talks today, we thought of, okay, let's use a chatbot. Solution for everything, right? So use LLMs. So that's what we went with. And then initially we thought, okay, let's take all of the data, let's fine tune the model, the LLM, and then the problem is solved. So now what is an LLM? So at this point, I think this slide is very, very, very overrated because you've been hearing about LLMs, RAG, and a lot of things over the last 2 days. But still, for those of you who are still not aware of it, I'll give a small one-liner. So LLM is a machine learning model which is actually trained on language, a lot of information that is over internet. Then when you ask it a certain set of questions, it answers based on the data it is trained on. Nothing more and simple. Alright, so when we thought of training our LLM, we ended up with few challenges. So what we needed was intense data preparation, because when we thought of the solution, it was like, oh, all right, so we got our use case to work on Gen AI solution. Let's get some chatbot and make it work. But then getting all of the data in the website and then get it more structured to train your LLM is not an easy task. So the thought of it itself was very painful to this day for us because we actually tried putting it into a structure. The second one is resources. And the third one is knowledge keeps changing constantly. And the reason why I skipped explaining resources in detail is I wanted you folks to look at this slide. So when we talk about LLMs at any organization, everyone gets excited. Managers, vice presidents, CTOs. And then when we talk about fine tuning, getting resources, talk about couple of GPUs, forget about high-end GPUs, just 5 lakhs, 6 lakhs budget. And they're like, can't we do it with software engineering? Do we really need a Gen AI solution for this? Right? So that's where we're like, okay, it's difficult for us to do this because we're not Meta. We do not have billions of dollars that we are pumping into our organization. We're just a service based company. So then we said, okay, let's build a RAG bot. So that's where our whole solution came in.
RAG. RAG stands for Retrieval Augmented Generation, as you can see. Now I'd like to explain RAG with an analogy. So let us think of a fourth grader who has knowledge about what he has studied up to his class, and he's really smart kid, and he can do stuff. He can recognize patterns. He can answer questions based on what he can see. So if we give this kid an open book exam, and we try to provide him an index and tell him and ask him a question, he's going to find in that index which chapter does this question belong to, and he's going to go to that page and try to read and answer based on that. So that is how RAG works on a higher level. And sometimes if we do not give him that context, he's going to imagine things, he's going to hallucinate. That is what we call as hallucination. So the main thing around which RAG rotates is vector database. So vector database, as its name suggests, it's a database of vectors. Vectors are floating point integers, an array of floating point integers. So they represent a text along with its semantics. So when you search a query, you're not searching based on keywords, you're trying to find based on context. And it's what we referred to previously, it's the cheat sheet finder. So how does vector database work? It's entirely centered around semantic searching. So semantic search, we have many different measures, but one famous measure is cosine similarity. So I hope you all know it, but if you don't, so that is how we measure cosine score of two different vectors. So the formula is given by a dot b, which is the dot product, divided by their magnitudes. So we get that vector. So when a user query is given, so when user query is given, so it tries to get the score for all the chunks, and then the score is computed and then ranked, and the top k chunks, k is the value that we fine tune. So that value is given back to the LLM. So here's a small example explaining how it works. So if the question that we are talking about, he belongs to a dog, and we have information about a puppy, pet, and a car. So puppy is going to get a higher score than a car, and pet gets somewhere in between because it is closer to that. So that is how semantic search works. So vector database is entirely centered around this one. So that is LLM without context, but with context. So it can answer based on that. So here's the RAG architecture. So this is the naive pipeline that we built, the first one. Yeah, so before we get into that, I would say the data that we given is most important part. So the data that is given has to be chunked, just like the cheat sheet. So it is chunked based on the tokens and everything, and then that is indexed using vector database, using embedding models, of course. So embedding models are those models which are used to produce those vector embeddings, and they are stored into a vector database, so that during the response generation process, whenever a new user query comes in, so an embedding model produces these kinds of embeddings, as we can see, and that is issued to vector database. So internally it uses that semantic score ranking mechanism, and then we get the relevant chunks, and then use based on prompts again, so using some guardrails and everything, we try to generate response using an LLM. So here is the final response. So that is about.
So Charan, you should stop rushing to the slides. So okay. So here's our architecture, and here's our presentation. Our talk is done, or so not. So we had this architecture, and we're like, okay, so whole implementation is ready, or whole design is ready. We are ready to implement everything, and then we jumped in like any naive Gen AI engineer who is in the room. I'm not pointing out to anyone. And we started making the changes. And then we got these challenges in there. So the first thing we felt is, okay, website is all about text. Let's just take it, chunk it, store it in the database. Done, right? And then the thing is, website does not just have text, it has PDFs. Because in our organization, for example, they put seminars and webinars on Salesforce, Oracle, and different things. They put all that content in the website, and then there is PDFs, and then there is Word documents. And do not forget the dynamic HTML content that changes over time. And then whatever we scrape today is not latest tomorrow. That's one few of the problems. And the other problem is we have embedded subdomains in our website. For example, for hiring, they use something like Naukari. Let's say they say naukari.osidigital.com, which is embedded in this site. So now you have to go to the other sites and sublinks which are embedded within. So these are like some of the challenges. And then one of the main ones is accuracy and relevancy. So we got all the data, at least the textual data, we fed it to the vector database. When we ask questions, we definitely got answers, but the question is it the relevant answer? So that's another challenge we stumbled upon. So also, so what we have, like I explained, is PDFs, images, and tables, dynamic content, and then like 900 plus pages in our website as of today. So it's osidigital.com. I mean, even until we started this solution, we never knew our website has those many pages. It was always the home page, probably a couple of other pages in the nav bar. And then this was very painful for us, and it even got us thinking, why did we even take up this project?
Then there's a challenge of dynamic content, as Srikanth has mentioned. So there's static HTML and there's dynamic HTML. So static HTML is something that after rendering by the browser also, it's the same. But when dynamic HTML comes into play, there is some JavaScript embedded within, which has to be executed by your browser engine. And the HTML content is generated at runtime. So there could be API calls, these could be other JavaScript functions. Then there's another problem, which is data variety. So there could be PDFs and images, as he mentioned. So we'll try to address one by one. So in order to address so many number of pages that we have used breadth first search algorithm. So instead of mentioning all of those 900 pages in an Excel and then adding one link and then deleting links regular basis, so we just give it the homepage URL, and based on that, the crawler tries to go into each link, clicking each link, and then trying to scrape it, do everything. So the next one would be handling the dynamic content. So here's how a dynamic HTML would look like, and here's some JavaScript code embedded within. So we'll try to do that JavaScript execution using Selenium. So Selenium lets us use Chromium driver, and then it lets us execute this JavaScript function, and then our new HTML comes up, and then using Beautiful Soap, which is a beautiful, as it mentions. I don't know why the name is Beautiful Soap though. So it tries to extract the tags and so it's like data cleaning mechanism. So as we say, garbage in, garbage out. So we do not try to put the entire HTML as is. We try to clean it and put it into a better format so that these embeddings get generated in the best way and retrieval happens in a more effective manner. So the images and tables inside the PDFs are a real challenge because there could be bar graphs, pie charts, and something that needs to be analyzed. But there could be the tables are really notorious, I would say, because we would ask what is the revenue in 2023, and it might not never answer because it's just 2023, and then series of numbers when a text parser comes up. So for the extraction of text, we used PyPDF2. So after doing a bit of research, we got to know that these are the best libraries that we can use based on the requirement. So each type of requirement would require a new module. So that's what we tried to do. So for the text extraction part, PyPDF2 worked really well as it would identify the page's layout. So if it is like 2 pages content, other libraries would be like go this ways, but it would actually go in a neat fashion as how a human would read. And then for the image extraction part, we used PyMU PDF, and then we noted down all of the images. We downloaded all of the images from that PDF, and then for the table extraction, we used PDF Plumber. So after extracting these images and tables, we try to summarize those images using vision models, and then put these summaries in their places exactly, so that whenever a user queries upon those images, we try to get that exact information. The verbosity of the summary entirely depends on our use case. So yeah, that's it. That's about this one.
Yeah. So the another problem that I was mentioning earlier was dynamic content change. So whenever content changes on a daily basis, initially what we did is we were re-rendering the whole thing. So basically dump everything that's in your system and then reload everything, which is very painful and not a good process. So what we did, we started using the content hashing and then checking what's in our current system versus what changed, and we started re-rendering only what's relevant and then removing what's not there as of latest. And then this became our updated ingestion engine. Of course, this is not so clear. Don't scold me yet. All right, so here's our storage and retrieval layer, and then there's our LLM layer that Charan was explaining earlier. So for text content, for images, PDFs, and everything, now we improved it, handling different kinds of data. And then we have this web scraping that we use for CSV, Excel, and different other formats. And then at the end, so all of this is fed to our system and being used. Yeah. So here's the thing. So like I said, we are being naive engineers when we are implementing this whole solution. Our whole agenda is to prove to our team, to our organization, that we are implementing a Gen AI solution, that we implemented RAG like everyone else. If possible, post it on LinkedIn, creating a post using a ChatGPT. Right? However, this is where we ended up. After all these optimizations, still it's taking 5 hours or more than 5 hours to render the whole content on our website, and it's very painful for us. Like, imagine if our content on our websites keeps increasing, how much more time it's going to take. And what if it breaks in the middle? We did not even take into account, like, how do we continue from where we left off if any of the process breaks? So then we had to optimize this, and believe me, so we thought so much about it. The solution is very simple, and I'll tell something at the end of this session why I'm telling it is simple. So we used async IO, as simple as that. So if any one of you are familiar with asynchronous processing, right? So we used async IO, and then initially we made all our requests to be async. Absolutely did not work, because it's not just asynchronizing only your APIs. You have database calls, you have different other areas where you have to optimize and parallelize everything that is in your system. So step by step we had to change the whole system, and at the end it came down until 40 minutes to scrape and process the whole website. So that's like 9x performance improvement on how much time it was taking originally.
So natively, a RAG engine is nothing but a search engine, I would say. And out of box, it does not work as a chatbot because it has certain challenges associated with it. So the first one would be the irrelevant chunks, because when a user queries, not every time that you are going to get the most relevant chunks that you are supposed to get, and your organization be like, why is the answer that? And that's our expression. So, so there is also a problem of having no conversation history, because RAG does not take into account the conversation we've had so far. So it's not a conversational bot. That's the main challenge. So we added a few layers to it. So we tried to add conversation history to it. So before we actually send the query to the vector database, we try to add another API call or another LLM call, which tries to give it the conversation history and then try to rephrase the query, which we call it as query fusion. And then we try to generate multiple variations of how a human would ask. Uh, I have an example in the next slide. And if we are trying to ask questions related to greetings or anything, we do not want those queries to actually go to the vector database and get something and waste our tokens. We do not want that. So we try to filter in the query rephrasing itself. We try to identify what this query is about. If it is just gibberish, we do not want to do any more API calls. We send some static responses. And if it is some general questions, we try to answer it in a different tone. And based on the situations, we can add more. But this entirely solved our use case. So here's an example of how a query would get rephrased. So if we ask the question, what are the vacancies in Hyderabad? So it is going to take into account HYD as Hyderabad and then vacancies as jobs or career opportunities. And then the possibilities are endless. So it will try to list every possible way human could ask so that we can get the most relevant chunks in during response generation. So another thing, so we're trying to increase the relevancy of the chunks we are going to get out of the vector database, because that's where the entire cream of the algorithm is going to lie. So we're not going to use the ranking, semantic rank that we are going to get out of the vector database. No, we're not going to do that. We are going to add a few more re-ranking mechanisms. So we do not want, let's say I have an example. So if we are trying to list job opportunities on our website, so we do not want them to be going to redirected to Naukri from our website's chatbot, which actually lies in depth in some other page and not at the surface level during the breadth first search traversal. So we have identified that as one of the metadata, that one of the key factors that we want to keep the users as surface as possible. And also, since we have multiple domains related to webinars, blogs, and job opportunities, we want to give weightage to our domain, and we want to navigate them to our domain as much as possible, keeping it in-house everything. So based on that, we try to identify re-ranking mechanism. So this was our new re-ranking score. So it's as you see, so it is going to take into account the semantic score, which is the vector database score that we are going to get out of the box, which is going to get weightage of alpha, and then PageRank is going to get a score of beta, and domain rank is going to get a score of gamma. Now these values can be fine-tuned, and believe me, it's easier to get to those values, but you'd have to do a lot of testing. It's like you are letting LLM develop your code, and you are testing the code that it generates, and you have to do multiple iterations of it to get to the actual result. So here's the final rack pipeline of every version. So yeah, so here's the data source, which is the website, and then we perform the similar data chunking that we are going to do, and then we're going to embed that information into vector database, as we have seen in the ingestion pipeline. Now the user query would actually get rephrased, and then the embedding model is going to generate those embeddings, and then the entire process happens. But here's where the magic happens. So the chunks we are going to get out are going to be re-ranked and then given to the LLM for the response generation. So now we will see the demo.
So before we go to the demo, so I'm not sure how many of the anime fans are here. So we just put together and nice. So we just put together a small summary of what we spoke in that pattern, and you can find the slides at pycon2025.srikanth.doddi.com, or you can also find in the PyCon website as well eventually. So now, through this whole journey, what we wanted to share with you all through the pain points that we faced is not everything needs to be solved with AI. So because the whole vibe and hype is going on with Gen AI, LLMs, and all that stuff. Yes, we can use it for the use cases where it makes sense, but for the most part, if we can carefully apply software engineering principles, that makes your solution more efficient, and you will definitely end up using software engineering principles here and there, and then at some point everywhere. So again, it comes back to how you engineer your whole solution. So that's the reason why we walked you through the whole journey. Like at the start itself, we already had the architecture ready with all the LLM, RAG, and all that stuff. But all the optimization that we did together along with you all through this journey is software engineering optimization. So we've been using async IO, we've been using different other re-ranking mechanisms and all those things. And since there are few fans of Demon Slayer, we also took opinions of few Hashiras on what they think about using AI for everything, and that's what they say. You can also find these things over these slides. Okay, cool. So I'll go to the last person. All right. So after this, we'll show a quick demo. It's not more than 40 seconds. So the value is more about what you listened so far. This is more like after this much pain. So this is what happened when we gave a demo to our management. So we simply went to them and then we said, here's the demo, right? So we said, we go to the website, you ask any question that you want. So now it gives you an answer, right? So from different pages, it pulls the links, it pulls all the information, textual and different other stuff. Like it gives job opportunities and all of those things. And this bot is currently available over the website. You can go to osidigital.com and you can test it, break it, and if you have any feedback to share with us, so we can still continue to optimize it. And so for the people who hasn't been involved in this journey, it's a simple chatbot. So why did it took so much time for your engineering team? So that's how it's been. But thank you all for being a wonderful audience. We'll be available here if you have any questions. Have a good day.
I was curious about the 40-minute process that you brought it down to. So, like, how frequently do you guys do it? The entire process of scraping the data from your website and then.
Yeah, we have a scheduler configured which runs every week. So it's
Okay.
weekly once.
But is it doing the entire website?
No, so that's what I'm about to answer.
Yeah.
So it does not even take 40 minutes all the time, because you've seen a slide where we're using content hashing and then doing a comparative
That's what I was
analysis.
going to ask.
So that's even lesser. So what we were explaining in that slide was for overall website scraping and then loading into the system, how much it was taking originally and then how much it is taking.
So most of the time it is the incremental changes and only
Yes.
the pages that were
Yes.
updated. Yeah,
Yeah.
makes sense. Uh,
So how exactly you are hazing that website and how exactly you are detecting that new changes occur and these are the new changes, simple enough.
We are putting everything related to a URL into a hash which is SHA-256. So it does have a limit, of course, but our content is not that much. So we try to hash it using SHA-256 and we put it against the URL in the database so that we can do a quick comparison and try to see if the hash has changed.